Hello, welcome back to Cracking the Cryptic, where today we've been asked to have a look at this Diabolical Sudoku from the Daily Telegraph. I think this was the one published on Friday, so that's yesterday. I'm losing track of days with New Year. Now apparently this might be quite difficult to solve logically, so hopefully we'll be able to make our way through it. As usual, I'll start with standard technique, by which I mean I'll look at 3 by 3 blocks like this one, and if I can see exactly two positions where I can place a number, so 8 would be a good example here, because of the 8 here and the 8 here, it can only go in these two positions. I'll make little pencil marks to remind myself of that fact, and we'll go through the solve like that until we get stuck, whereupon I may need to use some more extensive notation, but we'll see how we go. So what can I see straight away? 5. 5 can only go here in the central square because of the 5 here and the 5 here and this 5. So we can place 5 there. 6s in this top left box. Where can we place a 6? You can see we have two 6s here and two 6s there. So in fact a 6 can only go right at the top there. So let's place that in. And 7s down in this bottom box. So this 7, and this 7. We can only place a 7 there, and we can pencil mark some 7s up in the top left nonette. Okay. See now this funny sort of X arrangement of numbers here. This is always quite an interesting pattern. We can therefore pencil mark 8s into these two squares because of this 8. Which allows me to pencil mark 8 into those two squares, and then we can use this 5 to do the same thing with the 5s, and we get a couple of pencil marks from that, but it seems nothing more. This 6 here interacts on this block with this 6 to allow us to pencil mark 6s into those two squares, and therefore these two squares. 1. There, not seeing much else immediately. 9s, no. Okay, so if we get into this situation where we've sort of done the pencil marks that are immediately obvious, and I might have missed, I've missed a 4. Look, if we look at this block here, this 4 and this 4 interact to allow me to pencil mark 4s into those two squares, but I can't pencil mark 4s down this column because I can't restrict the 4s to just two squares. They're, you know, I'd have to put them in 3 squares like that, and I don't want to do that yet. So now when we get stuck, we're going to have to try and identify one of two things, I'd suggest. The first is we can look at columns or rows or blocks where we have a lot of given digits. So for example, column 5, we need to place 1, 2, 6 and 9. So you can see this square here is restricted to just 2 cells. I'm not seeing anything much better than that. Or we can look for weak areas of the grid where rows and columns that may not have lots and lots of digits, but they have lots of different digits interact. So I'm looking now actually, if we look at column 9, you can see we've got 9, 7, 2 and 3. But here in row 2 we've got 8, 5 and 6 and a 1 here. So there are 8 different numbers that can see this square. So what can this square be? It can't be 1, it can't be 2 and 3, it can be 4, it can't be 5 or 6, it can't be 7, can't be 8 and can't be 9. So this square in fact is a 4, which is, as I say, that sort of thing is just practice. The more you practice, the more you'll see those things. So now I'm going to take a closer look at column 9. This square looks quite restricted as well, doesn't it? Because 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so this square also, it's called a naked single, and a computer would spot it instantly, but when we have to solve it by just using our eyes, it can be a real nightmare. So that's good though, because now we've got 1, 6 and 8 to place in the column, and you can see that we have an 8 and a 6 here. So in fact this square has to be a 1. Let's put that in. That's great because that's going to interact on this 3x3 block to allow us to make those pencil marks, which has two effects. I suppose the first is that we've now got this 1, 8 pair in the column, in column 2. So we've got 2, 3, 4 and 9 to place, which means this square is restricted, but only to a choice of 2 or 9. 2, 3, 4, 9, nothing else better there. But also now we know that we must have a 3, 5 pair. We need to place a 3 somewhere in the block, and we know the only open squares correspond with the positions of the 5s. So we get a 3 here. So now row 8 is very restricted, and we're looking to place 2, 4 and 9, which ironically is completely unhelpful. So I'm going to have to go back to the 5. This 5 and this 5, you can see they interact with this 5 to force a 5 into this square. Now the moment I place a 5 in that square, because of the earlier pencil mark of the 7s, I now know there is only one position left that a 7 can go in this 3x3 block. So I can immediately write that in 2. And you can see this is now very, very helpful. 5 interacts with the 5, 3 pair down here, allows me to place a 5 here and immediately place the 3. And now we know, of course, that these two squares must be 1 and 9. And you'll be ahead of me because you'll look over here, see the 1. So in fact, that must be in this order. Now, where can we place a 1 in the central 3x3 block? Well, this one and this one mean there's only one square we can place it in, that's there. This 9 interacts on the middle 3x3 block as well, and let's complete the pencil marks over on this side with the 9s. Now, also do the same thing. Let's have a look at the 2 now and its interaction on this 3x3 block, forcing a 2 into one of those two squares. And now this 3x3 block is almost finished, because now we have a 2 and a 9 in both of these squares. So we know that the 2 and the 9 have to appear in some order in these two squares. So there's no way the 6 can interfere with that. If we were to place the 6 here, our logic would be saying that we need to place the number 2 and the number 9 in this square. Well, that's clearly not possible. So this 6 is not correct, which means this 6 must be correct. Let's put that in. That means that there is a 6 in one of these two squares. Let's be diligent about our pencil marks. And this square must be a 7 because it's the only place left for a 7 in the central nonette. And we can pencil mark 7s up here. And the 7 here and the 7 here interact to allow us to form a 7-9 pair in this 3x3 block. So it's all chaining relatively smoothly at the moment. The central row now needs a 2 and an 8. Well, we combine that with the logic we've already used on this square to say that an 8 can only be in one of two positions. Well, we now know the 8 must be in the central row, because otherwise that central row won't have an 8. Therefore, this must be the 2. Therefore, we can pencil mark 2s into these two squares. Pencil mark 3s here because if we know there's a missing 3 from this nonette, and this 3 here sorts that out. So 3 and 4. And just checking, so that means this is a 4 obviously, and we can pencil mark some 4s down here. So far this has been okay, so I suspect we're going to come to a sting in the tail any moment now. You can see we need a 1 in column 3 and there's a 1 here, so we place the 1, immediately unwind the earlier pencil mark with that 2 there, pencil mark 1s into these two squares. This 2, can we do anything with that? Nah, not quite. And we're left with the numbers, what's it going to be, 3, 4 and 9 into these squares, so that allows us to pencil mark the 4s, pencil mark the 9s, and to be honest, in this sort of situation I would pencil mark the 3s into the 3 squares. I know that's a slightly lacks logic there according to my pencil marks, but I'll forgive myself. So 2, 3 and 9 needed for row 2. Can't do anything with that. Let's just check a couple of the other numbers. And what we might have to start doing in a minute is to pencil mark some of the remaining squares that can only contain 2 digits, because normally with a very hard Sudoku puzzle, and I mean very hard, I don't just mean hard, if you do a hard New York Times Sudoku puzzle, this method should be enough. But when you get to seriously nasty puzzles, you quite often need more notation. So we'll just have a quick look now, but then we might have to start thinking about identifying squares that can only contain 2 digits. Column 5 maybe. We need to place 1, 2, 6 and 9, but we've got 6 pencil marks here. So 1, 2 and 9 into either of these squares, and we have a 1 and a 2 here, and a 6 indeed. So this square here can only be a 9. Let's put that in. Oh, not an 8. A 9. There we go. That means that we can remove the 9 from there. In fact, therefore, a 9 can only go into this square. That's the only position a 9 can go in. Over here. 9, 2, and 6. Back to little marks. Okay, now I am going to start. I can see these two can only be a 2 and a 3, so let's put that in. Chasing down the columns here, just trying to see. What I'm looking for is linkages between the numbers, just to see whether or not there are any patterns that might jump out. I'm probably going to pencil mark row 8 now as well, so let's just take a quick look at that. What do we need? We need 2, 4 and 9. So this square is very open. This one isn't. That's a 2 or a 9. So that's starting to look interesting to me. 2, 9, 7, 9 and 2, 3 here. What's this square? This square can be a 3, 4 or a 7. 3 or 7. Okay, now let's stare at this. Hang on. Yes, I think there is something here, which is called something like a WXYZ wing or something. But the much simpler way of thinking about it is something called a bent quadruple. So let's imagine that rather than the arrangement you see here, this square, this square, this square and this square were all in the same column. It would be very easy for us to look at those squares and see that there was a quadruple, and we would be able to eliminate the numbers 2, 3, 7 and 9 from the rest of the column. Here we don't have something quite that powerful, but we do have something that we can use. And the way that a bent quadruple becomes powerful, I'm going to try and explain it now the way I think about it, which might not help you, but what we need to look at when we find these bent quadruples is the relationships between the numbers, because we will find that one of the numbers in the bent quadruple, or we may find that one of the numbers in the bent quadruple has a different property to the others. So let's go through them and we can see what I mean. So firstly, let's look at the number 2. You can see this number 2 sees this number 2. So all of the number 2's in our bent quadruple see each other. And I think the term for that is that it means that they're restricted. I think that is the technical term that's used. So let's think about the number 3. Now the number 3's see each other because although they're not in the same column, they are in the same box. So they are restricted. Let's look at 7's. Now the 7s don't see each other. This 7 does not see this 7. And this will be key. This means that the 7 is non-restricted. And what we need to just test now to make sure that we have a bent quadruple that's useful is that the 9 must also be restricted. We only want one non-restricted number. So let's look at 9s now. 9s are restricted because this 9 here sees this 9. So good. We have a useful bent quadruple here, and we need to think about the number 7. So let me show you what I mean. Let's take this square. This forms part of the bent quadruple, and it can obviously contain 1 of 2 digits. So if it's a 7, you can see immediately that we could eliminate this 7, for example. What if this is a 3? If this is a 3, this forces this to be a 2, this to be a 9, and this to be a 7. So either way round, there is a 7 here or a 7 here. And that interacts on this block. This block can never contain a 7. Otherwise we would have a problem. So this is the critical stage, I think, to the next number in this puzzle. That means this must be a 9, which means immediately that's the 7. And hopefully that's going to be very helpful in making more progress with this puzzle. Now I've got to be a bit careful here about using my pencil mark notation properly. So let's look at this now. Those 5s. I think we could have found the 5 before I did that trick there. So this 5 and this 5 interact with this 5 and this 5 on this 3x3 block, meaning this is a 5. And that's useful in terms of the XYZ ring, because we now can use the 9s. 9, 9, and this 9 here. So this one has got to be a 9. 9 like that. It's going to allow us to pencil mark 9s down into these 2 squares. And you can see that we need the numbers 2 and 4. I'm going to notate this just because this 2, 4 is such a heavy restriction along here. I was hoping that this WXYZ wing would be enough to crack the puzzle, but it now appears not. So I'm going to have to keep staring at it a bit longer. Another look at column 5. So we need to place 1, 2, and so this is a 1, 2. I'm going to notate that. Just looking for a Y wing here. Let's have a look at column 6. So here we need the numbers 1, 2, 3, 4, and 9. So that's got loads of possibilities, I think. 1, 2, 3 here. Look at that. It's nearly a Y wing. We have got a bent triple, but for the Y wing to work, we need this to just have 2 possibilities, not 3 possibilities. So that is frustrating, but maybe. Oh, hang on. Let me just carry on down the column here. So we need 1, 2, 3, 4, and 9. So this square can be 1, 3, 4, and 9, I think. Am I missing something there? I don't want to miss something. I'm sure you've all got there already, but the reason I'm staring at this cell is that I've noticed there's another WXYZ wing if I can get rid of a 1 in this square, because then we've got another bent quadruple, this time on the numbers 2, 3, 4, and 9. And that might allow me to eliminate a number from here, which is going to give me a Y wing. That would be beautiful. So let's think about how we eliminate a 1 from this square. Is that possible? Let's have a look at row 9. So there's a hell of a lot of options for these squares, but 1, 3, 4, 6, 8, 9. So let's just check. 1, 3. Looks like 4 is possible, doesn't it? 6, 8, and 9. It's not that bad. This square will be more restricted. That can only be a 1 or a 6. Okay, so this square here can't be a 5 anymore. That has to be a 6 or an 8. Aha! Yes, 1, 6, 8 along. So let's have a look at along row 9 now. You can see we've got 1, 6, and 8 as a triple in these 3 squares. So we can eliminate the 1 here. Now we're right back where we wanted to be, because let's look at this 2, 3, 4, 9 bent quadruple again. Now remember what I said before. We need to have, once you identify a bent quadruple, we have to test its properties to make sure that it has only one non-restricted number. So let's go through the exercise again, because I think it's important. Now, if we have a look at the number 2, you can see that this number 2 here and this number 2 do not see this number 2. Okay, so this number is not restricted, so we cannot have any other non-restricted numbers, otherwise we can't use the property in question. So let's test 3. This 3 here sees this 3 here, so that's fine. There are the only 2 3s in the quadruple. Oops. Now 4s, these 2 4s see each other, they're the only 4s in the quadruple, that's fine. And this 9 here sees this 9 here, so that's fine. So we're looking to test the number 2 and to ask ourselves what happens with the number 2 in this situation. So let's pick this square. If this is a 2, clearly I can eliminate the 2 from this square here. If this is a 4, what happens? If this is a 4, we'd eliminate this 4 here, and you can see now in the column we have a 2, 3, 9 triple. So again, I'd be able to eliminate this 2. So either way round, I get to eliminate the 2 from this square. Now why do I think that's important? Well, now we have a much simpler structure in the puzzle. This is the classic Y-wing, which we covered, I think, last week. There was a Y-wing into a Y-wing last week. This week we've got this square, and this square, which form a bent triple. Now, bent triples are a bit less complicated than bent quadruples, because now we're just looking at the so-called pivot square, the central square of the bent triple, and because each option, or each of the wings of the Y, only has 2 options, watch what happens. So if this is a 2, you can see this square is a 1. If this is a 3, this square is a 1. So we need to hunt in the grid for squares that can see this square and this square, because we know neither of those squares, well, those squares that we find that can see both of those squares, cannot contain a 1, and I'm sure you've all got there first. But look at this square. This square sees this square and it sees this square, so we know this square cannot contain a 1, and that is massive. Now the eagle-eyed among you will notice there's a cut in the video here, and sorry and apologies to those of you who watched the video when it was first published, but I patiently explained how the Y-wing worked and how a 1 could not go in this square, and then promptly put a 1 in this square. Now this sometimes happens with live solves, so apologies for that, but I thought it was better just to correct it rather than to get a volley of comments saying that I messed it up, which I did, but I think that as I say, the logic explained was completely consistent. It just required me instead, once noting this square here can't contain a 1, to put in a 6. Now once you put a 6 here, the whole puzzle collapses. I can show you that quickly now. So this now has to be an 8, this will be a 6, this will have to be an 8, this will have to be an 8 up here because of the earlier pencil marks, look. This 8 here means that we can unwind the 8 and the 1 over on this side. Now what next? well, this square here has to be 4 now. We need to place a 7 and a 9 in this triple, or in this nonette. So that's going to be a 9, that's going to be a 7. And you can see that the puzzle's solved. So thank you very much for watching. I hope this was an interesting solve today. I certainly think that it was a difficult Sudoku, this one, with a couple of quite difficult spots, and definitely appreciated the recommendation. So thanks very much for that, and we'll be back soon with another edition of Cracking the Cryptic. Oh, one more thing, please, if you do enjoy our videos, please do subscribe to the channel. We really appreciate that. We'll see you again soon.